with sort of monotonically decreasing cost. And that's why we're taking a systems approach, working across the entire industry to optimize the full stack, right? Whether it's the data center, silicon, the system software, or the app server, bringing it all together as one system and optimizing and using the power of software. And our aim is to offer the lowest cost, highest scale infrastructure to build both cloud and next generation of AI workloads. And it all comes down to delivering the most tokens per watt per dollar. And that's sort of the ultimate equation for us. And we're riding, multiple S-curves, right, across silicon. Think of it as classic Moore's law plus system software optimization and the model optimization. It's the compounding effects of those three S-curves. And we're doing all of this with real speed, right? So when anything gets ready, you want to bring it into the fleet. In fact, Azure is the first cloud to bring NVIDIA GB200s online and do so at scale. Now, Azure now leads the performance from a single GB200 with NVLink 72 rack, generating as an astonishing number of tokens, right? 865,000 tokens per second. It's the highest throughput for any cloud platform. And of course, there's nobody better to talk about this than Jensen Huang. Let's roll the video.
Thank you so much, Jensen, for joining yet again for our Build Developer Conference. At the end of the day, our joint goal is to be able to deliver more intelligence to the world. In some sense, you can even say it's tokens per dollar per watt. And so I just wanted to be able to maybe get your perspective on all this, maybe starting, in fact, with the very start of what has been our industry, which is Moore's Law.
So excited to be here, Satya. In fact, 2 years ago, we had just launched the largest AI supercomputer in the world together on Azure. This is the big change in how computing works now. With our new CUDA algorithms and new model technology in your new AI infrastructure on Azure, together, all of that together, 40x speed up over Hopper. That's just an insane speed up in just 2 years.
You want to talk about the compounding effects of software that then add to all of what we're doing together?
We still want architecture compatibility. We want the rich ecosystem to be stable so that software developers' investments and all of the AI developers' investments and all your infrastructure customers' investments get to be distributed and amortized across the entire fleet.
You want to speak a little bit to what happens to utilization and the diversity of workloads that get all accelerated?
One of the benefits of CUDA is that the install base is so large. Another benefit of CUDA is that, on the one hand, it's an accelerator architecture. On the other hand, it's fairly general purpose for some of the heaviest workloads. Our two teams are working on accelerating data processing by 20x, 50x, transcoding video, image processing, models of all kinds. All of those different types of algorithms map wonderfully on top of CUDA. Our job is to make sure that that fleet and that workload, all of the workloads of your data center are fully accelerated. The fleet is fully utilized for the entire life of the fleet.
It's not just tokens, but it's all workloads per dollar per watt. Can we really accelerate them all as we continue to innovate across both the hardware and the software boundaries?
And Satya, thank you for your partnership and leadership and the alignment between our two organizations to build the most advanced infrastructure in the world, the most advanced AI factories in the world, and the best of times are yet to come.
Thank you, Jensen. So in fact, the largest GB200-based supercomputer is going to be Azure. And so we're very, very excited about scaling this and making it available to all of you as developers. In fact, we are continuing to expand Azure. We now have 70+ data center regions, more than any other provider. Over the past 3 months alone, we have opened 10 data centers across countries and continents. And of course, we're building a complete AI system. That means it includes cooling to meet the demands of AI workloads. With Maya, we had introduced and engineered this Sidekick liquid cooling unit that also supports now GB200 in this closed fashion, such that, closed loop fashion so that you can really consume zero water. On the network side, our newest data centers built for AI have more fiber optics than we added in all of Azure before last year. I mean, think about that, right? So there is, it's just even the data center design is just mind-blowing for me when I go back and see them. It's unlike anything that at least I grew up with. We're connecting our DCs with this AI WAN, 400 terabyte backbone. So think about, it's not about all the type of workloads, right? Whether it's inference or training needs, when you distribute them, the AI WAN connects this data center footprint. And of course, the AI applications themselves, right? It's not just about having an AI accelerator or a GPU. You need all of your compute. And every app needs storage and